Hello everyone, this side Mayank Jhunjhunwala from IIT Kanpur. So today I'm going to discuss system of particles chapter with you. So let's start. So in system of particles, what we basically read about is about center of mass and all that stuff. Center of mass, rigid body, their center of gravity, points, momentum conservation, velocity of center of mass, all these kind of stuff we read in this chapter. So let's start with what is center of mass first. Mm, So let's start with what is center of mass. Center of mass of a body is defined as a point at which whole of the mass of the body or all the mass of a system of particle appears to be concentrated. What it means that let's say consider you have any body like this, and the whole mass of the body is distributed. No, like some masses here, some masses here, some masses here, and some masses here. Since all the mass is distributed in the body, so what you want to find some point at which you can concentrate the entire mass of the body. Let's say for this body, center of mass will be somewhere here. So at this point, if you apply the entire mass of the body, then it can be said that you are basically acting on the body itself, like the point at which entire mass of the body can be concentrated. That point is known as center of mass. So I hope you understood it, at which the whole of the mass of the body appears to be concentrated. In physics, we say that the center of mass is a point at the center of distribution of mass in space. Obviously, means the center of mass distribution means, let's say here mass is more and here mass is less. So your center of mass would be somewhat closer to this point. Like it would be in basically middle of middle of not middle of the geometry, but it is on the middle of the mass distribution. So if let's say here mass is more and here mass is less, so center of mass will be shifted slightly towards this thing because it is in the middle of mass distribution, not in the middle of geometry of the shape. So wherein the weighted relative position of the distributed mass is the sum of zero. In simple words, the center of mass is a position that is related to an object. So we can say that the average position of all the parts of a system or the mean location is the center of mass. जैसे मैंने आपको बताया, center of mass is nothing but you can say that you can ignore the entire body and you can do any calculation with the body at the center of mass, because the center of mass is a null representation of the body itself. So whatever you want to do with body, you can do with center of mass. It will be applied to the entire body. So it is a point where force is usually applied that results in linear acceleration without any angular acceleration. Okay. So basically वही चीज लिखा हुआ है कि if you want to do anything with body, you can do with center of mass. It will be applied to the entire body. Okay. So this was the main concept behind center of mass, and I hope you got it. So let's move ahead. When we are studying the dynamics of motion of center of system of particles, what we need to bother about the dynamics of individual particles of the body. So these dynamics can be studied very easily with the help of center of mass. And one more thing, center of mass is represented as COM. So in coming slides, I will be saying center of mass is COM. So please remember that COM is nothing but center of mass only. Then the motion of this unique point is identical to the motion of single particle whose mass is equal to the sum of all individual particles of the system and resultant of all the forces exerted on all the particles of the system by surrounding bodies, or action of a field of force is exerted directly to that particle. The same thing which I told you in the previous slide. If you want to apply some force on this body, let's say 5 Newton, 6 Newton, and you are applying force here, then here, then here, and the sum of all these forces is 5 Newton. So basically what center of mass do is you don't need to apply 5 Newton force at different points of the body. You can just apply the summation of force, that is 5 Newton, on the center of mass itself, so that it will be applied on the entire body. So center of mass is that thing only where you can apply the force at the center and you can leave all of the points. So that is center of mass, and the point is called the center of mass of the of particles. The concept of center of mass is useful in analyzing complicated motions of system of objects, like uh, when a particle explodes into fragments or when two objects collides. In सब चीजों में what we use is the concept of center of mass. Why? Because center of mass is a important concept. Without this, you can't do anything basically. So please remember this thing. Center of mass is some point where you can do the calculation for the body, leaving all other points, you can concentrate only on center of mass and you will get the same result. Okay, so let's move ahead. Okay, now what is a rigid body? Rigid body. So rigid body is something like, let's say you have some body, let's say liquid, let's say some gas. Gas is not rigid. Why? Because if you have a, let's say, balloon, and balloon is filled with gas, so when you want to puncture the balloon, you just prick it and it gets punctured. So it is not a rigid object. So rigid body is something in which the relative distance between the particles of the body does not change at all. So that is what is written here. Rigid body is something which may be which cannot be deformed. Like it is rigid, which is non-deformable, or rigid, which cannot be deformed. Its shape cannot be changed. So an extended body is also a system of infinitely large number of particles having an infinitely small separation between them. When a body deforms, read this. When a body deforms, the separation between the distance between its particles and their relative position changes. So this thing is written here. But what we need in rigid body is that this location, this relative location should not change. A rigid body is an extended object in which separations and relative locations of all its constituent particles remains the same, wo change nahi ho sakti under all circumstances. Means at any cost, the relative separation between any two particles, this is your rigid body, so the relative separation between this particle and this particle should not change. Like if this is, let's say, x distance, then at any circumstance this distance should only remain x. Maybe body becomes something like this, then also these two particles will remain here and here, then also distance between them should be x only. So basically, what is the main concept of rigid body? It is this, like the relative separation between two points on a rigid body does not change under any circumstance. If it is rolling, moving at any cost, the relative separation should not change. That kind of bodies are known as rigid bodies. Okay, so this was the concept for rigid body. Moving ahead. Okay, so coming on to center of mass. So what is center of mass? So center of mass is something like what we just studied about center of mass. So now we will study how to calculate it. So basically, for calculating center of mass, there is one formula. Let's say you want to calculate center of mass for x coordinate. So XUM is equal to, as it is written, sigma I equal to 0 to n MI xi divided by entire mass, capital M. So this is when you have the body in which you know the distribution, and the distribution is uniform throughout the body. But in case the distribution is not uniform, then you will use the concept of integration. So in that case, XUM would be integral dm x divided by total mass. Okay, so these are the two relations from which you calculate the XUM or YCUM or ZCUM, anything else. When you use this formula, this is used when you know that the separation of mass in the body is entirely uniform. See, here it is written. We extend the formula to a system of particles. The equation can be applied individually to each axis. So x-axis, y-axis, and z-axis. So basically, what I am doing is I am multiplying the mass of each and every particle of the body with its distance from the origin, with its x distance. Why? Because I'm calculating x coordinate of center of mass and dividing it by the entire mass of the body. Similar thing I will do with y coordinate and with z coordinate. So this is the thing which I do when I know that the mass distribution is uniform and when I know the separation of particles. But when the case is something like some place mass is more and at some place mass is less, so at those points I have to use integration because that is more generalized form of calculating center of mass. The above formula can be used if we have point objects, but we had to take a different approach if we want to find center of mass of an extended object like a rod. We have to consider differential mass and its position and then integrate it over the entire length. So basically, I am considering a differential mass. Let's say this is my rod. This is my rod. So I'm going to x distance. Let's say I reached here at a distance of x, and I took dm mass. This is dm. So I calculated dm and I multiplied by x. Then I integrated it over the entire length from 0 to L, and then divided it by capital M, which is the mass of this entire rod. From that, I'm calculating xum, then ycum, then zcum. So basically, this formula is very very less it can be used in very less conditions, like when you know the exact distribution, but the generalized format is this only. So try to remember this thing because this thing will be used many a times in calculating center of mass. Okay, so let's move ahead. Okay, so now let's calculate the center of mass of this rod. So how to do that? Again, same thing. Go to x distance, cut a dm mass segment. Let's say it would be dx. It would be separating the length dx. Then assume total mass to be capital M, which is written here. Then and the density is uniform because I am considering a uniform rod. Then center of mass lies on the x-axis. Why? Because I'm taking this as my origin. This is my origin, and sorry. So basically, what I'm doing here is I'm taking this axis as my x-axis. This is my x-axis and this is my y-axis. Okay. So basically, in x-axis, I went x distance long. I cut out a segment of dx. So basically, what is the mass of this dx segment? It would be total mass divided by total length, m by L. So this is the mass of a unit segment, and then I multiply it by dx to get the mass of this dx segment. So mass of this dx segment is nothing but dm, which is capital M by L multiplied by dx. So this is the mass of this segment, and then I integrated it over the entire length from 0 to L. So m by L dx integration from 0 to L. This is the what I did, and then as I said, the formula is the formula is, as I told you, formula is nothing but integral dm into x dm into x divided by total mass capital M. So that's what I did here. Dm is nothing but m by L dx multiplied by x and divided by capital M. So from here, m and m would get cancelled out, and what would be left would be dx into x by L. Integration of x dx, I know it is x squared by 2, because we know that integration is x power n plus 1 upon n plus 1, so it would be x squared by 2 from 0 to L. So I will be getting L squared by 2 divided by L. So 1 L will cancel out, and what will be left is L by 2. So here the center of mass coordinate is L by 2, which is again xum only. Why? Because it is x-axis. For ycum would be 0, and zcum will also be 0 in this case. So I hope you got the application of this concept. You have to just calculate dm, then multiply it by x, then integrate over the entire length from 0 to L, from 0 to L, and then divide it by capital M, and you will get your answer. Okay. So this was the main concept behind it. So moving ahead. Okay. So now move on to two particle system. Two particle system. Mouse is not working. So moving on to two particle system. So what is there in two particle system? In two particle system, basically we are considering two particles, one and two. So there would be, let's say, two particles, and their separation is R1 and R2 from the main origin. So and distance between them is d. Why? Because we are considering rigid body, and in rigid body distance remains unaffected. So what I'm basically saying is the distance will be as it is. So in the same way, now I will calculate RCM. How to calculate RCM? Same way, sigma m r upon capital M, where r is the distance from center of mass. So from the origins, then RCM, I know this is M1 I1 plus M2 R2 upon M1 plus M2, because sigma MIRI for there, since there are two objects, so M1 R1 plus M2 R2. Then similarly, I will calculate XCM M1 X1 plus M2 X2 upon M1 plus M2, and YCM M1 Y1 plus M2 Y2 upon M1 plus M2. I just use the same formula, and then I calculate these distances. This X1 and X2 are nothing but the distance only. So when we will do some question and you understand this, how to do this thing, x1, x2 is something from is the distance from the point about which we are calculating the center of mass. So from here, now what we want is we want that RCOM, we need to calculate the center of mass only. So what we want is RCOM should be 0. So I did that, and what I found is uh, M1 is equal to M2 R2, and then from there, the main relation, which is we known as M2 R2 is equal to M1 R1. Whenever this relation holds only in that case when you are taking distance with respect to center of mass. So when you take distance with respect to center of mass, if there are only two particle system, let's say there are two particle system, one particle is here, another particle is here, and somewhere here is center of mass. So what this formula basically says is, this formula says is m1 r1 is equal to m2 r2. Like the center of mass will be at some point where the mass distribution is uniform. So basically, if there's two particle system only, and you are taking the r1 r2 about center of mass, then m1 r1 is equal to m2 r2. This is a very important relation which you need to be there, which should be in there in your brain, that whenever you take distance with respect to center of mass, then m1 r1 is equal to m2 r2, where m1 and m2 are two particles. So this thing is only written here, and then for calculate, then you can easily calculate it. Like let's say this is your one particle, this is your other particle, and let's say center of mass is something here. Why? Because this thing is let's say 2m, and this thing is let's say m. So obviously बात है कि your center of mass will be some slightly towards 2m because their mass distribution is greater. So what I'm saying is this distance and this distance. So basically x, this is x1 and this is x2. So what I'm basically saying is m1 x1 should be equal to m2 x2. So 2m x1, since we are taking it about center of mass only, so 2m x1 should be equal to m x2. Okay. So from here what we are getting, then x2 should be equal to 2 times x1. Okay. So this is the basic relation. And then to calculate x1, what you do, x1 is nothing but total distance between these two particles, which is x1 plus x2, x1 plus x2 multiplied by the mass for which you want to calculate. Let's say since you want to calculate x1, so you will take this mass, which does it invert because m is inversely proportional to distance. Okay, so since you want to calculate x1, so you will not take the x1 mass, so you will not take 2m, you will take m here. So it would be m upon m plus 2m, which is 3m. So basically, this thing is your answer, and you know that x2 is equal to 2x1. So put here 2x1. So 2x1 plus x1 will be 3x1. So 3x1 into m upon 3m. So see, you are getting x1 only. So since you are getting x1 equal to x1, so this formula is correct. So I hope you got it. So basically, what you basically do, you use this formula for calculating the distance from center of mass. If you know that your particle is somewhere here and some other particle is somewhere here, and you know the distance between these two, so basically, if you want to calculate the distance from center of mass, you can use this formula, which is the total distance multiplied by the opposite mass upon total mass. From there, you can calculate the distance between the particle and the center of mass. Similarly, you can do for this particle, you will take this mass upon the same mass, upon total mass, and this is the total distance between them. So these dynamics are only for two body particles, only for two body particles. You can do these things. So otherwise, you can't do these things. Okay? Then moving on to center of mass of system with cavity. So how to do with cavity? There's nothing. Just calculate the original mass without cavity and then calculate it with cavity and then subtract it. You will get the answer. So let's say, okay, let us do this question with the, let us do this concept with some question only. So we will study it ahead. Okay, so now calculate it for a uniform disk of radius capital R. So how to do it? Again, same thing. You have to calculate dm multiplied by coordinate, which is x, y, r something, divided by total mass capital M. Okay, so here how to calculate dm from, let's say here you go x distance. Okay, since here it is not something there is not there, so starting from here go y distance, cut a small ring of dy segment. Then there is mass would be how to calculate the mass. Mass is nothing but, since the whole ring is there in pi r square by 2. Why pi r square by 2? Because it is like half the area of the ring, half the area of the circle, because it is only half circle. So m by pi r square by 2 into the area of this ring. Area would be how much? Circumference, which is pi r, because it is semicircle, multiplied by dy, this one. So pi r dy, which is they are taking dr. So m upon pi r square by 2, which is m upon total area multiplied by the area of the strip. This is your dm. So dm multiplied by capital Y. Y is nothing, just the center of mass of this coordinate, which is y here only, since you have taken y. So you know that for a ring, matlab, you don't know this thing, so let me tell you that for a ring, the center of mass is at the 2r by pi distance from the origin. So for a ring, the center of mass of a ring is at 2r by pi distance. This is a result you need to calculate for a ring. Then only you can calculate for a disk. So there I have not shown for the ring, so please take it as granted. But you need to calculate for ring also. When you will calculate for ring, you get it that it is 2r by pi. So basically, this is a result which you need to learn only, that for a ring, the center of mass is at 2r by pi distance. So that's what I use there, divide by total mass m. So now integrate it from 0 to r, you will get your answer as 4r by 3 pi. So from here, you can learn two results, that for a ring, y center of mass is at 2r by pi distance, and for disk, it is at 4r by 3 pi distance. So learn these two results because you can directly use them in your questions. But how to calculate them, I've just told you. But if you need to calculate for ring also 2 by that also you can calculate using the same concept. There you can just go at x distance and again cut a segment dx, then and integrate it for the entire ring. You can easily get 2 by pi. So from there we use it in the disk derivation, and from there we got that center of mass for a disk is at 4r by 3 pi. Similarly, since you know that since there is a uniform mass distribution, so x center of mass would be zero only, and z center of mass would be zero only. We just need to figure for y, and y is at 4r by 3 pi. Okay, so this way again you just use this formula and calculated the center of mass. So let's move ahead. Okay, so now let's move on to some questions. What it is saying, it is saying two identical rods each of mass small m and length l. Okay, mass is m and length is l, and are connected as shown in figure. Okay, locate the center of mass. मतलब मेरे को इस पूरे सिस्टम का सेंटर ऑफ मास बताना है. So since we are given that दोनों का मास equally है, so m1 is equal to m2 is equal to capital M. Okay, and both length is l only, so l1 is equal to l2 is equal to l. So now what we need to do, we need to calculate center of mass. So since here we know the distribution, so we don't need to integrate, we can directly use this formula, sigma mi xi upon capital M. So here total mass would be m1 plus m2. So m1 plus m2, and sigma mi xi is m1 x1 plus m2 x2. M1 is m1, x1 is 0, because the choice of axis depends on you only. So I have just chosen axis something like this. From here, from here. This is my origin, this is my x-axis, this is my y-axis. So I know that the center of mass of this rod would be at this point only. So for this rod, the center of mass is at 0 point, so m into 0. And for this rod, center of mass is at this distance. And this distance is nothing but L by 2. So m0 plus ml by 2 upon capital M plus capital M, because both the rods have same mass and same length. So from here, you got that m and m cancel, and your answer would be L by 4. So from here, you can say that what you will get m l by 2, और upon नीचे 2m है तो नीचे हो जाएगा 4m. So basically your answer would be L by 4. So your answer would be L by 4. So L by 4 is something here, so this is your center of mass point, x center of mass. And again, y cum would be 0, z cum would be 0 only. Okay, so this is your center of mass point. You just need to use sigma mi xi upon sigma m, and from there you calculated your result as L by 4. Okay, so moving ahead, this question: two blocks of mass 10 kg and 4 kg are connected by a spring of negligible mass. Okay, so let's say this is one block, and you have connected it with the spring with two other block, and you are saying that one is 10 kg and another is 4 kg, are placed on a frictionless horizontal surface. So there is a surface, frictionless and horizontal. An impulse gives a velocity of 14 meter per second to the heavier block. Okay, so let's say this is a heavier one. So here it gains some velocity of 14 meter per second as written here. So the velocity of center of mass will be what? मेरे को ये निकालना है. Okay, so this question को solve करने के लिए अपने को what we need is the concept of collision and all those things. So firstly, let us read that and then we will come back to this question. So how to calculate the velocity of center of mass? It is nothing but the velocity of individual particles multiplied by their masses divided by total mass. So let's say there are three particles, one particle, two particle, and three particle. So just calculate. So just multiply their masses with their velocities. m1 v1 plus m2 v2 plus m3 v3 upon total mass. So you will get the velocity of center of mass. And momentum is nothing but the mass multiplied by the velocity. So since you have calculated the velocity of center of mass multiplied by total mass of the body, so you will get the momentum of center of mass. Okay. Similar way you can calculate acceleration of center of mass also. What you need to do, you just need to multiply the acceleration of each particle of the body with the respective masses m1, m2, m3, mn, so on. So m1 a1 plus m2 m2 plus m3 a3, as such, you will need to just multiply all those and then add them. And then again divide by capital M, you will get acceleration of center of mass. Okay. And then you can use the formula here, we divide by, since F external is capital M into acceleration of center of mass only. Okay, then impulse you must have read earlier also, but let me tell you, impulse is nothing but change in momentum. Impulse is something when you apply a very greater amount of force in a very small interval of time period, let's say dt. So the force applied in some time period dt causes a change in the momentum of the particle. So that change in momentum is known as the impulse, and you just write it in this form: f dt is equal to delta p, where delta p is change in momentum. F is the very large force applied for a very small time interval. So when you integrate this, you will get a change in momentum, and that change in momentum is only known as the impulse. So in center of mass system, you just need to do all these calculations with center of mass, nothing else. Okay. So move ahead. Moving on to collision system. So what is collision? Let's say there are two bodies, M1 and M2. They are moving with velocities V1 and V2. And then V1 and V2 are such that they are moving towards each other. So after collision, one will move like this and other will move like this. So what you need to do is, in collision, there are two concepts. Firstly, remember this thing. Since whenever there is no external force, momentum remains conserved. And in the case of collision, there is no external force. There is a force between these two particles, but the two particle system is a system only, and I am considering the external force which is external to these two particles. So there is no external force. So momentum of these two particles will remain conserved only. So m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 v2 dash. Why? Because there is no external force. So momentum will remain conserved. So m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 v2 dash, because there is no external force, so momentum remains conserved. Same goes with energy. Since they say there is elastic collision, in elastic collision there is no loss of energy. In elastic collision, there is no loss of energy. That's why we can say that the energy will also remain conserved. So since initially the energy was half m1 v1 square plus half m2 v2 square, so after collision also the energy will remain same. Why? Because it is elastic collision. In elastic collision, the body deforms certainly, so the energy for deformation comes from the kinetic energy of the particles initially. So at that point, energy is not conserved. But for elastic collision, there are two principles: momentum conservation and elastic collision. In any type of collision, momentum will always remain conserved because there is no external force during collision. And for elastic collision, energy will also remain conserved. Then what is coefficient of restitution? Coefficient of restitution is nothing but, this is the extended version. The main definition of coefficient of restitution is something like this: velocity of separation divided by velocity of approach. Okay, so this is the main definition of elasticity, coefficient of restitution, sorry. So basically velocity of separation upon velocity of approach. So from here you can see that how they are separating. They are separating with v1 plus v2. Why? Because you just need to calculate to take the separation velocity. So here, if m1 is going here this side, then also it is separating, and v2 is going this side, then also it is separating. So basically we will add these two. So here it is written wrong. It would be v1 dash plus v2 dash upon, and how they are velocity of approaching. How they are approaching with v1 plus v2 velocity. So your answer would be v1 dash plus v2 dash, which is velocity of separation, divided by velocity of approach, which is again v1 plus v2. Okay. So this is your coefficient of restitution. Ignore this thing. This is wrong. Then E is equal to 0 of completely elastic collision, because in completely elastic collision the energy remains conserved. So in case of completely elastic collision, E is 0. Completely inelastic collision, E is equal to 1. And then if then there comes the mass considerations, that if m1 is greater than m2 and m1 is less than m2, all these things you can just do using these two formulas. So no need to remember this thing. Then when remember this thing, when both the masses are equal, then v1 dash is equal to v2 dash and v2 dash is equal to v1. Like the velocity will remain, the velocity will interchange. Like if they're coming like v1, then if m1 is v1, then m2 will go with v1, and if m2 is v2, then m1 will go with v2. So basically, velocities interchange in case the mass is same. So please remember this one. This is important slightly. Whenever the mass of the bodies are same, and when they are moving towards each other with some velocity, and then after collision, the velocities just interchange, and all the things remain the same. In case when both the masses are same. So this was the concept of collision. So let's move on again to the question which we were doing. So what's asked in this question? It is they are saying there are two blocks of masses 10 kg and 4 kg. So one is 4 kg one and another is 10 kg one. They are connected by a spring of negligible mass and placed on a frictionless horizontal surface. Okay, so this is a frictionless horizontal surface. And what they're saying, let me erase this diagram slightly over. So uh, okay, so then an impulse gives a velocity of 14 meter per second to the heavier block in the direction of lighter block. Okay, what I did is I gave an impulse to the heavier block and that gave that a velocity of 14 meter per second. So I need to calculate the velocity of center of mass. So I know the velocity of center of mass is nothing but sigma m1 v1 plus m2 v2 upon total mass. That's what I did here. So basically, what this side is gives a velocity of 14 meter per second to the heavier block. Heavier block is of 10 kg. So 10 into 14 plus 4 into 0 because we have given that there is no velocity which is given to the lighter block. So for lighter block, the velocity is 0. For heavier block, the velocity is 14. So 10 into 14 plus 4 into 0 upon total mass. This is the velocity of center of mass. So simple question, simple application of formula sigma m1 v1 upon sigma mi vi upon sigma m is the total mass capital M. And here capital M is nothing but the summation of these two masses, which is 14 kgs. So from here you easily calculate the velocity of center of mass, which is nothing but 10 meter per second. Okay. So simple application of formula. And then move on to this question. In this question, what is asked? A 20-gram bullet. Okay. A 20-gram bullet passes through a plate of mass 1 kg and then comes to rest inside the second plate of mass this one. Okay. As shown in the figure. Figure is not given here. So okay, no problem. It is found that the two plates initially at rest now moves with equal velocities. Initially वो रेस्ट पे थी तो बेसिकली मान लो कि इनिशियल वेलोसिटी बुलेट की v1 है और जो वेलोसिटी जिससे हर प्लेट मूव करती है वो v2 है वाई बिकॉज इक्वल वेलोसिटी दी हुई है तो मान लो कि v2 वेलोसिटी से हर प्लेट मूव करती है तो ऑब्वियसली बात है मैं कंजर्वेशन ऑफ मोमेंटम लगाऊंगा बिटवीन बुलेट एंड दीस टू प्लेट्स देयर इज नो एक्सटर्नल फोर्स देयर इज ओनली बुलेट एंड दीस टू प्लेट्स सो देयर इज नो एक्सटर्नल फोर्स. So basically, initial momentum, which is only for bullet, because both the plates are at rest, so their momentum would be m into zero. So zero is zero. So basically, mv1 is equal to m1 v2, which is the new velocity of bullet, m1 v2 uh, plus m2 plus cap plus m plus m2 plus small m into v2, which means that all the particles will move with the same velocity because they are saying that they are moving with equal velocity, and the bullet also gets embedded in the second plate. So bullet is also moving with the same velocity. So all the particles, these two plates and the small bullet are moving with velocity v2, and this thing is equal to the initial momentum, which is equal to mv1. So since all masses are given to us, so we will put all the masses and we will get a relation between v1 and v2 where v1 is the initial velocity of the bullet and v2 is the final velocity of the system. System here means both the plates and the bullet. So v1 is equal to 200 v2. This is what we are getting. One second. So as I told you earlier, also in any type of collision question, you just need to conserve momentum and nothing else. Whenever you conserve momentum, you will get one equation. So this is your master equation, v1 equal to 2v2. Then what is said to you? Find the percentage loss in the initial velocity of the bullet when it is in between m1 and m2. Neglect any loss of material of plate due to action of bullet, which means that you don't need to consider the piercing material goes out of the plate, all those kind of stuff. You don't need to consider, neglect all those kind of stuff. Just calculate the percentage loss in the velocity. So how to calculate that? Let's say when the velocity of the bullet when it comes out of the first plate is v3. Why? Because you need to calculate loss when it is between the two plates. Like let's say this is one plate and this is two plate. So basically, what you're saying that one bullet is coming from here, it pierces this one and goes and embeds here. So basically, what is the percentage loss when the bullet pierces the spear and comes here? So you need to calculate the velocity loss in the bullet when bullet pierces one plate and is going to embed the other plate. So basically, you need to calculate the velocity loss when it is at this point. So how to do this thing? Again, the momentum conservation between this point. Let's say this point is one, and between this point, let's say this point is two. Okay. So do momentum conservation between 1 and 2. So initially again 0.02 into V3 because it is 20 gram. So again you need to do calculations in SI unit only. So 0.02 into V2. Sorry for the pen. 0.02 into V3 is equal to 0.02 plus 2.980 V2. Why? Because this initial plate what they've done here. Okay, so they are actually conserving momentum between this point and this point. You can also conserve between this and this, but since they are conserving between these two, so let's conserve between these two only, between 2 and 3. So here the velocity would be, let's say, V3. So 0.02 into V3 is equal to, they are giving with equal losses. So again, 0.02 plus 2.980 V2. So from here, what we are doing is we are just conserving the momentum between this bullet and this plate. This will also remain conserved only because there is no external force. So 0.02 V3 is equal to 0.02 plus 2.980 V2. From here, you will get V3 equal to 150 V2, where V3 is the velocity between these two plates and V2 is the final velocity of this plate. So you just calculated the initial velocity V1 and V3, the relation between these two. So now what you need to calculate, you need to calculate the loss in the velocity. So for loss, you just need to divide the change by the original velocity and multiply it by 100. So what is the change? Initial velocity was 200 V2. Final velocity is 150 V2. So 200 minus 150 divided by original, which is 200, into 100. Solving this will give you 50 upon 200, which is 1 by 4. 1 by 4 into 100 is 25%. So loss is 25%. Okay. So let me explain it once again. So basically what we did here is we just take one bullet and shoot it towards two plates, and it is saying it the bullet will pierce one plate and will go ahead between these two plates and then goes to second plate and gets embedded in second plate. So what you need to calculate is the velocity change in the bullet when it is gone from first plate and it's between the two plates. So firstly, what we did is we applied the momentum conservation between the initial condition when bullet was fired and the final condition. So what I got was the initial velocity V1 is equal to 200 V2. This is the initial velocity. And then what I did is I applied momentum conservation between the point when the bullet is between these two plates and the point when the bullet gets embedded in the second plate. So in this case, I applied momentum conservation in between the bullet and the second plate. So 0.02 into V3, V3 is the velocity when it is between the two plates, is equal to 0.02 plus 2.90 plus 2.980 into V2. V2 is with V2 is with both. So here V2 is with multiplied with both 0.02 and 2.980. So from here you got that 0.02 V3 is equal to 3 V2 because 2.9 plus 0.02 is 3. So from here you got V3 is equal to 150 V2. So this is the velocity when it is between the two plates, and this is the velocity when it was coming. So you just subtract both, divided by original velocity, multiplied by 100, then you will get the loss in the velocity, and you need to calculate it in the form of percentage. So multiplied by 100, so 1 by 4 into 100 is 25%, which is your answer. Okay. So I hope you got this. This question was slightly good question to revise all the concepts of collision. So I hope you got it. Let's move ahead. Okay. So let's move on to this question. A circular plate of uniform thickness, a circular plate आपको दी हुई है with uniform thickness as a diameter. Okay, so this question, as I said to you, is something around cavity problem. So how to do this question? This is very important. This is again and again asked in JEE mains. So please see to it clearly because it is very important one. So a circular plate of uniform thickness, a diameter of 56 centimeter. The diameter of the entire plate is 56 centimeter, and then a circular portion of diameter 42 centimeter is removed from one edge of the plate. मतलब इसका this diameter is 42 centimeter, which means this distance from here to here, it is 42, and the entire diameter, this entire one is 56. So here it is wrong, it would be 56 and it would be 42. Okay, then you have to find the position of center of mass of the remaining portion after the plate is removed. So how to do this thing? Again, same thing. The firstly need to calculate the center of mass of the original plate. So total mass of the original plate would be, let's say small m is the mass of per unit area. So total mass would be m into pi r square. Initially r is initially diameter is 56. So radius would be half 56, which is 28. So pi r square into capital into small m, which is the initial mass of the original disk. Then calculate the mass of the removed disk. Removed disk mass would be m into pi r square, and here r would be 42 by 2, which is 21. So this is the mass of the removed disk. So total mass of the entire plate would now be M minus capital M minus capital M1, where capital M1 is the mass of the removed plate and capital M is the mass of the entire plate. So now you need to calculate the center of mass. So you know that the center of mass of the removed plate is at for the original plate, when the plate was not cut. Let's say your plate was something like this, then the center of mass would be at zero position. Let's say this is my axis, so initially the center of mass is at 0 point. But when the plate was cut, the center of mass would shift for this the center of mass for this removed plate would be at this center. It would be at its center only. So its center would be at 7 centimeter. So basically at 7 centimeter there would be center of mass. But now what you need to calculate is the center of mass of the remaining plate. So how to do that thing? You just need to do this thing like the initial center of mass was at 0. So 0 is equal to m1 r1 plus m2 r2 upon total mass. Like center of mass for this plate is at 0 is equal to m1 r1. M1 is the mass of the removed plate. So m1 into where is the center of mass of this removed plate? It is at the center of this plate, which is at 7 centimeter distance, because 28 minus 21 is 7 centimeter. Because you know now that, let's say this is the original center. So initially it was 28, and now the plate is moved one. So let's say the center of this mass would be at somewhere here, and you know that this distance is 21 centimeter. So from this point to this point, it would be 28 minus 21, which is 7. So m1 into 7, okay, plus this removed mass, let's say m minus m1 into its center of mass, which is, let's say, at distance r, divided by total mass. Total mass is capital M only. Okay, so I hope you got it. Now you just need to do it equal to 0. So m1 into 7 is equal to m minus m1 into r. From there, you just put the values, capital M and small and m1 values. From there, you get r2 equal to minus 9 centimeter. So the center of mass of the now of the plate after removing the smaller plate is at 9 centimeter to the left of the bigger circle, which is like from center to 9 centimeter from here, somewhere here only. Minus 9 means the distance from this origin to left of the plate. Why? Because it is minus 9. And you know that to the left of origin, here there are minus coordinates. So that's why minus 9 centimeters somewhere here. Okay. So once again, let me do this thing, how we calculated it. We calculated this by using the same formula. We know that the center of mass of the original plate was at 0. So 0 into center of mass of this plate. Let's we just consider it a two particle system. One particle is the removed mass and the particle is the left mass. So the center of mass of the removed mass would be at 7 centimeter from center. So m1 into 7 plus center of mass of the left object would be, let's say, at r distance. So m minus m1, which is the left mass, into center of mass of that object divided by total mass, which is capital M. So you just need to equate it to 0. From there, you will get the value of r is minus 9 centimeter, and this minus 9 centimeters from the center. So minus 9 will be somewhere here only. So 9 centimeter to the left of the center of the bigger circle. Here it will be center of bigger circle. Left of the center of bigger circle. Okay. So I hope you got the concept. It was slightly tricky, but if you do it once, then you can do it forever with any geometry of body. We just need to consider, you just when doing these type of questions, you just need to consider it as a two particle system, one particle with the removed mass and one particle with the left mass. and then apply sigma m1 x1 upon m, then you can easily calculate the center of mass of the remaining object. Moving ahead with the last question, what it is saying that a point mass of 1 kg collides elastically. Okay, elastic collision, which means you can conserve energy with a stationary point mass of 5 kg. After a collision, the 1 kg mass reverses direction and moves at the speed of 2 meter per second. Okay, 2 meter per second square per second होगा यहाँ पे. Then which of the statements is correct? Okay. So first thing first, since there is collision, momentum conservation you can apply, and elastical is also given, so kinetic energy conservation is also there. So just apply that thing. Mass is 1, initial velocity, let's see u, plus second body mass is 5 kg into its velocity is 0 because it is stationary, is equal to final momentum. Final momentum 1 kg mass reverses, so 1 into, since it is reverses, so we take a minus with the speed of 2 meter per second, so 1 into minus 2 plus 5 into second particle velocity we have not given, so let's take it equal to v. So we have got one equation, u is equal to minus 2 plus 5v. Then again the elastic is collision. Collision is elastic, so we can even equate the energy. So initial energy, which is half mv1 square, which is v1 is equal to u, we have took it, and the second particle was at rest, so its kinetic energy was 0 initially, is equal to final kinetic energy. Then we got the second equation in u and v. So two equation and two variable between u and v, you can easily solve it and get the value of v and u. Okay. So what is asked to us, the total momentum of the system is 3 kg meter per second. Since we have got the final velocities of both the particles, we can calculate the velocity of center of mass with sigma m1 v1 upon total mass, m1 into v1 plus m2 into v2 upon total mass. So we got the velocity of center of mass as this thing, and final kinetic energy would be half m1 plus m2 into v square. So because we know that the kinetic energy of the body is nothing but the kinetic energy of the center of mass only. So we calculate the center of mass velocity kinetic energy, which is half into total mass into velocity of center of mass. So kinetic energy is 6 by 8. And again, momentum is again, we can calculate the center of mass only. So total mass into velocity of center of mass. So this is the final momentum. This is final kinetic energy. And this is the final velocity of center of mass. So now let's check 3 kg meter per second. This is correct. Momentum of 5 kg mass after the collision is 5 kg mass का momentum पूछा है ना अपने से. तो 5 kg mass velocity is v, and v is equal to 1 meter per second. So momentum would be mass into velocity, which is 5 into 1. So it would be 5 only. Since it is given 4, so it is wrong. Then kinetic energy of the center of mass is 0.75. Yes, it is 0.75. So this thing is correct. Total kinetic energy of the system is 4 joules. It's again wrong. The kinetic energy of center of mass is only the total kinetic energy of the system. So these two must be equal only. So A and C are correct and B and D are wrong. Okay. So I hope you got the concept, you got the chapter. This is a very, very easy sort of chapter. When we start studying about rotational dynamics, this is the basic starting of rotational dynamics. Momentum conservation, energy conservation, and calculation of center of mass are very basic things. So please practice some questions on these concepts, and so that you become if you will give enough practice, then you can easily do these type of questions. Okay, so let's end this lecture. Okay, thank you.